For centuries, humanity has gazed up at the stars and wondered, are we alone? As our telescopes grow more powerful and our understanding of the universe expands, the answer may finally be within reach. But if we did make contact with an intelligent alien civilization, it could upend everything we think we know about our place in the cosmos. So keep watching, because by the end of this video, you might just look at the night sky very differently. This is the age-old question that has captivated our species since the dawn of time. Our ancient ancestors, looking up at the night sky, saw stories and gods in the stars, and speculated about celestial beings. As time progressed and our understanding deepened, we began to realize that these twinkling lights were other worlds, perhaps not too dissimilar from our own. The advent of the telescope in the 17th century was a turning point, allowing us to probe deeper into the cosmos than ever before. Fast forward to the 21st century, we now have technology that's able to peer into the farthest corners of the universe, and even detect planets orbiting distant stars. Our search for extraterrestrial life has become more sophisticated, driven by advancements in technology and an expanding understanding of the universe. As our telescopes grow more powerful and our understanding of the universe expands, the answer may finally be within reach. To estimate the number of civilizations in the cosmos, astronomer Frank Drake proposed a formula, the Drake equation. Now, what is this Drake equation, you may ask? Well, it's a scientific approach to quantify the variables that would be relevant to the existence of extraterrestrial civilizations. Imagine the universe as a vast ocean and we're trying to estimate the number of fish. The Drake equation is our fishing net. It's a bit more complex than that, but you get the idea. This equation factors in 7 key variables. The first is the rate of formation of stars suitable for the development of intelligent life. Imagine this as the size of our cosmic fishing pond. The second factor is the fraction of those stars that have planetary systems. This is akin to asking, how many of these stars have the right kind of homes for our fish? Next, we consider the number of planets per solar system with an environment suitable for life. This is like figuring out the number of potential fish-friendly spots in each home. Then we factor in the fraction of suitable planets on which life actually appears, and the fraction of life that evolves to become intelligent. This is like asking how many of these spots actually have fish, and how many of those fish are smart. The sixth variable is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. Think of this as determining how many of these smart fish are waving at us. Lastly, we factor in the length of time such civilizations release detectable signals. This is like asking, for how long are these smart fish waving? So you see, the Drake equation helps us estimate the number of civilizations that might be out there, waving at us across the cosmic ocean. While the Drake equation doesn't provide a definite answer, it does show us that the possibility of intelligent life out there is far from zero. But if there are potentially so many civilizations, why haven't we heard from them? This is the Fermi paradox. The Fermi paradox presents a fascinating conundrum. Given the vast number of stars in the universe, many of which likely host habitable planets, it would seem logical that intelligent life would have arisen elsewhere. Yet so far, we've heard nothing but cosmic silence. This paradox, named after physicist Enrico Fermi, is a quandary that has puzzled scientists for decades. The Fermi paradox isn't so much a paradox as it is a clash between our expectations of a vibrant, chatty universe and the stark silence we've encountered. But why is that? Some propose that intelligent life is exceedingly rare or short-lived. Civilizations might rise and fall too quickly to make their presence known on a cosmic scale. We could be swimming in a cosmic sea, shouting into the void while everyone else has already drowned or moved on. Others suggest that we're looking in the wrong way or at the wrong time. Imagine trying to have a conversation with a Neanderthal using a mobile phone. The technology and language would be incomprehensible to them. Could it be that we're the cosmic Neanderthals, not yet advanced enough to perceive or understand the signals from other civilizations? Or perhaps we're simply not listening hard enough. Our search for extraterrestrial intelligence is still in its infancy. Our radio telescopes have scanned only a tiny fraction of the sky at a limited range of frequencies. The silence we've encountered might be due not to a lack of chatty neighbors, but to the vastness of the cosmic ocean we're trying to explore. The Fermi paradox forces us to confront the reality of our situation. In the grand scheme of the universe, we're newcomers, trying to make sense of an ancient, vast cosmos. It reminds us that while we've come a long way in our understanding, we've barely begun to scratch the surface. The Fermi paradox reminds us that the absence of evidence is not evidence of absence. Despite the silence, the search continues. SETI, or the Search for Extraterrestrial Intelligence, is leading the way. This organization, along with others of its kind, are at the forefront of the quest to answer the age-old question: are we alone in the universe? SETI's primary objective is to detect signals from advanced civilizations beyond our solar system. To achieve this, they employ a variety of methods and tools. One such tool is the radio telescope, an instrument that is capable of detecting and analyzing radio waves from space. These telescopes are not looking for radio waves in the conventional sense, like those used for broadcasting. Instead, they're tuned to frequencies that are naturally quiet, making it easier to pick out any potential signals that stand out from the cosmic background noise. In addition to radio telescopes, SETI also utilizes optical telescopes. These are designed to detect pulses of light, such as those produced by lasers. The idea here is that an advanced civilization might use such a technology to communicate across vast interstellar distances. But what exactly are these telescopes looking for? Well, they're on the lookout for signals that exhibit signs of artificial origin, such as a narrow bandwidth or a repeating pattern. These are the kinds of signals that nature simply cannot produce, and would therefore suggest the existence of an intelligent source. The search for extraterrestrial intelligence is a vast and complex undertaking. It involves scanning millions of stars across a wide range of frequencies, a task that requires both time and resources. But despite the challenges, SETI remains undeterred. While the search has yet to yield a definitive signal from an extraterrestrial civilization, it's important to remember that we've only just begun to scratch the surface. The universe is unimaginably vast, and our search has so far been limited to a tiny fraction of it. As our technology continues to advance and our search methods become more refined, the chances of making contact will only increase. While we have yet to find a definitive signal, the search is far from over. We continue to peer into the cosmos, hopeful that one day we'll receive a response. But what if we did make contact? What would that mean for us? The implications of first contact are vast and far-reaching, resonating across both scientific and philosophical spheres. Take a moment to imagine. We receive a signal, undeniable proof that we are not alone in the universe. Suddenly, our status as a singular intelligent species on a lonely planet is challenged. We are no longer unique, no longer alone. From a scientific perspective, first contact would herald a new era of discovery. It would affirm the possibility of life beyond Earth and validate the countless hours spent peering into the cosmos in search of the extraterrestrial. The data we could potentially gather from such a civilization could revolutionize our understanding of biology, physics, and technology. It might even offer solutions to challenges we currently face on Earth, such as climate change or energy production. On the philosophical end of the spectrum, first contact would compel us to reevaluate our place in the grand scheme of things. We would be forced to confront our anthropocentric worldview, reconsidering notions of morality, religion, and identity. Are we special? Are we important? If there are others out there, what does it mean to be human? Beyond the scientific and philosophical, there's the sociological aspect to consider. How would society react to the news of extraterrestrial intelligence? Would we unite in our shared humanity, or would our differences become even more stark in the face of the alien? And then, there's the question of communication. If we did make contact, how would we understand each other? Would we be able to find a common language, or would their means of communication be completely unrecognizable to us? These questions, and countless others, underscore the magnitude of what first contact would represent. It would be a moment of profound change, a moment that would challenge and redefine our understanding of ourselves and our universe. Contact with an intelligent alien civilization could upend everything we think we know about our place in the cosmos. So where does that leave us? Are we alone? That's the question we've been orbiting around. We've delved into the age-old question, explored the math of the Drake equation, contemplated the enigma of the Fermi paradox, and highlighted the tireless efforts of SETI. We've also speculated about the profound implications of making first contact with an alien civilization. The universe, vast and mysterious, is teeming with potential for life as we know it, and perhaps, life as we don't. This exploration has underlined a fundamental truth: our understanding of the cosmos is constantly evolving. Today's fiction could be tomorrow's fact. The possibility of intelligent life elsewhere in the universe is more than just a thrilling notion. It represents a potential paradigm shift in our understanding of our place in the cosmos. So keep watching the skies, because by the end of this video, you might just look at the night sky very differently.